10.1, the language of hypothesis testing. All right, so in 10.1, we're going to look here at a lot of verbiage and just being able to start defining things so that we can use them here later in chapter 10. All right, so the first example, we have a friend flipping a coin, and if you win, if you come up with heads, if it's tails, the friend wins. Well, suppose the outcome of 5 plays is all tails. Is your friend cheating? Okay. So first we want to determine the probability of getting 5 tails in a row, assuming the coin is fair. Okay, and that all of those flips are independent. Okay, so we do that probability. We looked at that in previous chapters, and so we know it's a 1/2 for each time. And so after we do all of our multiplication, we get 0.03 for our probability, or 3% chance that this is going to happen. And so that tells us that if we were to flip 5 coins 100 different times, we would expect only 3 out of those 100 times to result in all tails. So this is pretty unlikely. Now, you can make one of two conclusions. Your friend just happens to be lucky, because it is possible for it to happen, though it's not very often. Or your friend is cheating because he's not using a fair coin, and therefore it changes the probability for those pieces. Okay? So you have to make that decision. All right, so this here is the heart of hypothesis testing. We make an assumption about reality, and then we look at sample evidence to determine whether it contradicts our assumption on those pieces. Okay. Now, a hypothesis is a statement regarding a characteristic of one or more populations. So we're going to be looking at just a single population parameters, for instance, proportion, mean, standard deviation, those types of things. Just looking at them one at a time, though. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. All right, so here are our steps. First, we make a statement regarding the nature of the population. Second, collect evidence. And then third, analyze the data. All right, now we have different statements. We have what's called the null hypothesis. All right, H sub 0, or read H naught on those, okay? And that is what is to be tested. The null hypothesis is a statement of no change, no effect on anything, okay? We're going to assume it's true until proved otherwise. The alternative hypothesis, H1, is a statement we're trying to find evidence to support. So this is what we believe is really happening compared to our null hypothesis. Okay? All right, so there are 3 ways that we can have the null and alternative hypothesis. We can have a not equal to, which is two-tailed, because it could be either less than or greater than. We could be less than, which is a left-tailed test. And then we could have a right-tailed test, which is greater than. Now notice there the H naught is always has the equals, and the H1, our alternative hypothesis, always is one of those signs. So either does not equals, less than, or greater than for those pieces. All right. Now the null hypothesis is the status quo. That is our baseline for those pieces, and we're looking to see if it's true or if our alternative hypothesis contradicts that. All right. Now, left and right-tailed tests are referred to as one-tailed because it's only one side, whereas the does not equal is a two-tailed. Notice that the left-tailed gives a less than symbol, and the right-tailed gives a greater than symbol. Okay, it's going to point kind of the direction you need to go for those pieces. All right. And then all of them, the null hypothesis again, as it equals. All right, so here we just need to determine is it two-tailed, left-tailed, right-tailed. All right, so we have this pharmaceutical company, 2% of the children taking the antibiotics experience side effects. The Food and Drug Administration think that it could be more than 2%. Okay, so the baseline is 2%, but we're thinking it's going to be more than 2%. So that means that our H sub 0 equals 0.02 for 2%. And our H1 is going to be greater than 0.02. Now notice they used P there because it's a population proportion. It's 2% of the proportion. That's of the population. Sorry, that's a proportion for those things. So that's why they used P for that. And it's right greater than because it's a right-tailed. It's more than. All right, the next one we have this Corvette. It's worth $59,000. They believe it is different from that. Okay, so since it's different, then we're going to do a does not equals. Now we're talking about the mean here for those values, and so that's going to be using mu as our parameter. Okay, and then finally here we have standard deviation in this bottle of detergent is 0.23. They think that it is filling, has less variability. Okay, so that means that we're going to have a less than. We use sigma for standard deviation with those pieces. So that's just being able to set up our statements so that later on we can do something with those pieces. Now there are some errors that can happen here, and so we want to look at where the errors are and what are all the total outcomes. Now our first two here are not errors. These are actually true outcomes. And so first we can reject the null hypothesis when the alternative hypothesis is true. So that's a correct decision on that. Now we're not going to say we accept the alternative hypothesis. It's always based on the null hypothesis is what you'll see here. So we either reject or do not reject the null hypothesis. Right? So when we reject the null hypothesis, that means the alternative had to be true. Number two, we do not reject the null hypothesis when the null hypothesis is true. Okay? On those. So those are the correct types of outcomes. 3 and 4 are where our errors come in. Here we reject, in number 3, we reject the null hypothesis when the null hypothesis is actually true. That is a type 1 error. And then number 4, we do not reject the null hypothesis when the alternative is true. That's a type 2 error. We should have rejected there. Okay? So this is just a chart putting all those things together. What is happening compared to our conclusions. All right, so kind of taking that back, looking back here at the pharmaceutical company and us believing that there's more than 2% of those being affected. Okay, so that's our hypothesis test, as we said before. So H sub 0, P equals 0.02. H1 is P is greater than 0.02. All right, so a type 1 error would mean here that the sample evidence leads us to believe that it's actually greater than 0.2 when it's not. Okay, and so we have to be careful of those pieces. A type 2 error would believe that we do not reject the null hypothesis when in actuality the value is greater than 0.02. Okay. All right, now finding the probability of those things. So alpha is the probability of a type 1 error, beta the probability of type 2 error. Now the level of significance, alpha, is the probability of making a type 1 error on those. Okay. All right. Now a few other things here. The probability of a type 1 error is that that increases. The probability of a type 2 error decreases, and vice versa. So one goes up, the other must go down. All right. Now I kind of stated this before. We never accept the null hypothesis We never accept the alternative hypothesis. We either reject or do not reject, okay, with those pieces. So, and it's the null hypothesis that we're always talking about. So we either reject the null hypothesis or we do not reject the null hypothesis. And it's kind of like court. We never say the person is innocent. We say they are not guilty, all right, for those pieces. All right, so again, looking at our pharmaceutical company, we want to be able to state the conclusions here for these. So let's suppose that the null hypothesis is rejected. State the conclusion. So in the statement, the alternative hypothesis is that the proportion of children taking the new antibiotic is more than 0.2. Because the null hypothesis is rejected, there is sufficient evidence to conclude the proportion of children who had this side effect is more than 0.02. So since we rejected the null hypothesis, we can conclude, again, that more than 0.02 were affected. The null hypothesis is not rejected. So what would that look like in that same scenario? Okay, because we did not reject the null hypothesis, there is not sufficient evidence to say that there is more than 0.02 affected. All right, so those are the definitions and things that you're going to look for here in 10.1.